The International Space Station flies 400 km high at speeds that defy gravity, literally, at 28,800 km per hour. It only takes 92 minutes for the weightless laboratory to make a complete circuit of Earth. Astronauts working and living on the station experience 16 sunrises and sunsets each day. Let's get to know a bit more. Did you know that the International Space Station was launched in 1998, more than 2 decades ago? Not very recent, right? The International Space Station ISS is a modular space station habitable artificial satellite in low Earth orbit. Let's be more clear. It is a multinational collaborative project involving 5 participating space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. The ownership and use of the space station is established by intergovernmental treaties and agreements. The station serves as microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, physics, and other fields. If you think that's all the information available on the International Space Station, you're dead wrong. Buckle up and make sure you have enough oxygen for an outer space journey. But before we start, make sure to subscribe and hit that bell to receive our latest notifications. The International Space Station is the largest man-made structure in space. It was built in pieces and then launched into space and assembled in orbit. The project, which began as an American effort, was actually long delayed by funding and technical issues. The project was first called Freedom in the 1980s by the United States President Ronald Reagan. President Ronald authorized the National Aeronautics and Space Administration (NASA) to build it within 10 years. It was redesigned in the 1990s to reduce costs and reach further international involvement, at which time it was renamed. In 1993, the United States and Russia agreed to combine their separate space station plans and visions into a single facility, integrating their respective modules and incorporating contributions from the European Space Agency (ESA) and Japan. The ISS program evolved from the Space Station Freedom, an American proposal which was conceived in 1984 to construct a permanently manned Earth orbiting station, and the contemporaneous Soviet-Russian Mir 2 proposal with similar aims. The ISS is the 9th space station to be inhabited by crews, following the Soviet and later Russian Salyut Program, which was the first space station program undertaken by the Soviet Union, and Almaz Program, which was a highly secret Soviet military space station program that began in the early 1960s, and Mir stations, a space station that operated in low Earth orbit from 1986 to 2001, and the United States Skylab, the first United States spacecraft launched by NASA. It is the largest artificial object in space and the largest satellite in low Earth orbit, regularly visible to the naked eye from Earth's surface. The station is divided into 2 sections. The Russian orbital segment ROS is operated by Russia, while the United States orbital segment USOS is run by the United States as well as many other nations. The first ISS component was launched in 1998, and the first long-term residents arrived on 2 November 2000, after being launched from the Balkonur Cosmodrome on 31 October 2000, comprising Russian cosmonauts Sergei Krikalev and Yuri Gidzenko, and American astronaut William Shepard, who flew up in Soyuz spacecraft. The ISS has been continuously occupied since then, for more than 21 years, the longest continuous human presence in low Earth orbit, having surpassed the previous record of 9 years and 357 days held by the Mir space station. There is usually 6 astronauts on board the station. They generally switch out about every 6 months so that no one spends too much time in space. The station is about the size of an American football field. It's located just outside the Earth's atmosphere. This is called low Earth orbit. It's not very high up, considering that some satellites orbit way higher. Over time, the ISS will slowly lose altitude. If nothing was done, the station would eventually burn up as it re-enters the Earth's atmosphere. To prevent this, the station must be periodically reboosted to stay in space. Since the International Space Station is a multinational collaborative project, the components for its in-orbit assembly were manufactured in various countries around the world. The United States components Destiny, Unity, the Integrated Truss Structure, and the Solar Array were fabricated in the Marshall Space Flight Center and the Meshed Assembly Facility. The Russian modules, including Zarya and Zvezda, were manufactured at the Khrunichev State Research and Production Space Center in Moscow. Zvezda was initially manufactured in 1985 as a component for Mir 2, but was never launched and instead became the ISS service module. The European Space Agency Columbus module was manufactured at the EADS Astrium Space Transportation Facilities in Bremen, Germany, along with other contractors throughout Europe. The other ESA-built modules, Harmony, Tranquility, the Leonardo MPLM, and the Coppola, were initially manufactured in the Thales Alenia Space Factory in Turin, Italy. The Japanese experiment module Kibu was fabricated in various technology manufacturing facilities in Japan, at the NASDA, now JAXA, Tsukuba Space Center, and the Institute of Space and Astronautical Science. The mobile servicing system, consisting of the Canadarm2 and Dexter grapple fixer, was manufactured at various factories in Canada, such as the David, Florida Laboratory and the United States, under contract by the Canadian Space Agency. The ISS consists of pressurized habitation modules, structural trusses, photovoltaic solar arrays, thermal radiators, docking ports, experiment bays, and robotic arms. Major ISS modules have been launched by Russian Protons and Soyuz rockets and US shuttles. The station is serviced by a variety of visiting spacecraft, the Russian Soyuz and Progress, and SpaceX Dragon 2, the Northrop Grumman Innovation Systems Cygnus, the Japanese H-2 transfer vehicle, and formerly the European Automated Transfer Vehicle ATV, and SpaceX Dragon 1. The Dragon spacecraft allows the return of pressurized cargo to Earth, which is used, for example, to repatriate scientific experiments for further analysis. As of November 2020, 242 astronaut cosmonauts and space tourists from 19 different nations have visited the space station, many of them multiple times. This includes 153 people from the United States, 50 from Russia, 8 from Canada, 9 from Japan, 3 from Germany, 5 from Italy. A NASA microgravity laboratory called Destiny and other elements were subsequently joined to the station, with the overall plan calling for the assembly, over a period of several years, of a complex of laboratories and habitats crossed by a long truss supporting 4 units that held large solar power arrays and thermal radiators. Aside from the United States and Russia, station construction involved Canada, Japan, Brazil, and 11 ESA members. Russian modules were carried into space by Russian expendable launch vehicles, after which they automatically rendezvoused with and docked into the ISS. Other elements were ferried up by space shuttle and assembled in orbit during spacewalks. During ISS construction, both shuttles and Russian Soyuz spacecraft transported people to and from the station, and the Soyuz remained docked to the ISS at all times as a lifeboat. The ISS provides a perfect platform to construct scientific research. With power, data, cooling, and crew available to support experiments, small and crewed spacecraft can also provide platforms for experiments, especially those involving zero gravity and exposure to space. But space stations offer a long-term environment where studies can be performed potentially for decades, combined with ready access by human researchers. Remote sensing of the Earth, astronomy, and deep space research on the ISS had dramatically increased during the 2010s after the completion of the United States orbital segment in 2012. Throughout the more than 20 years of the ISS program, researchers aboard the ISS and on the ground have examined aerosols, ozone, lightning, and oxides in Earth's atmosphere, as well as the Sun, cosmic rays, cosmic dust, antimatter, and dark matter in the universe. The ISS simplifies individual experiments by allowing groups of experiments to share the same launches and crew time. Research is conducted in a wide variety of fields, including astrobiology, astronomy, physical sciences, material sciences, space weather, meteorology, and human research including space medicine and the life sciences. The ISS shows that multiple countries and private companies can work together for the peaceful exploration of space, born out of the ashes of the Cold War, as a way for the United States and Russia to focus on a common goal. The station has largely remained unaffected by earthly politics. It operates thanks to the cooperation of 15 nations working under formal international agreements. In brief, the ISS is the largest orbiting laboratory ever built. The first stage was launched in November 1998 by Roscosmos. Since then, the United States, European, Japanese, and Canadian space agencies have contributed more modules, robotic arms, and giant solar arrays. Its primary purpose is to develop the capability to live and work in space. The experience gained there should pave the way for more complex structures in space, such as a permanent base on the Moon and missions to Mars. This sums it up and brings us to the end of today's episode. If you like this video, please subscribe to our channel and hit that bell for more interesting videos. And make sure to share your opinions with us in the comment section below. I will see you in the next one. Take care.